Welcome to the Virtual Foundry podcast. We are on volume 2, episode 14. Today is Friday, September 24th, 2021. The time is 11:47 a.m. and the temperature is a nice cool fall 66 degrees Fahrenheit. That's 19 degrees for you Celsius users. If you've been following my temperature reports, you may have picked up on the fact that I love temperatures in the 60s. It's just a really pleasant environment outside. So happy to be in this lovely time of late September where the weather is just spot on. Today, we're going to be talking about the state of the metal 3D printing industry today. I'm Tricia Cease, president of the Virtual Foundry, and with me as always is Brad Woods, our founder, inventor, all-around science guy. Say hello, Brad.
Hi, everybody.
So as I mentioned, we're talking about the metal 3D printing industry today, a little bit about how we got here, where we're headed. And as we take a look at 3D printing or additive manufacturing as a whole, it has been around for a little while. Talk about that history with us, Brad.
Right. So early versions of plastic and polymer 3D printing go way back to the early 80s. And there was a bunch of different strategies. There was stereolithography, which we now know as SLA. The plastic stuff didn't come online until a bit later, but in recent history, many of those patents have started to expire. Recent history being maybe the last 10 years or so, a little bit more than that. So we saw a strong uptick of people in the maker community coming up with 3D printing solutions that were very powerful and very inexpensive. So primarily, I'm talking about the RepRap project, and it's been an interesting journey. And much of what started with hobbyists in the RepRap project is now the foundation for commercial additive polymer 3D printing. And what we've done is taken the reasonably mature plastic additive manufacturing methods and combined them with relatively mature powder metallurgy strategies. So powder metallurgy, as we know it today, it started becoming significant in the 1920s. And at that point, auto manufacturers started using it for fabricating complex shapes, for self-lubricated bearings, things like that. And over time, it's only grown. So like a recent estimate I heard was that the average automobile has 20 to 30 pounds worth of powder metallurgy manufactured parts in it. So what the Virtual Foundry has done is combine these two technologies. We've taken polymer additive manufacturing, FDM 3D printing that's based on filament, and combine it with powder metallurgy. So the materials that we produce are polymers that are highly loaded with metal. In fact, they're so loaded with metal that it's kind of the other way around. It's more like it's metal particles that are held together by a very small amount of thermoplastic. And we've used this strategy to form the shapes. Once the shapes are formed, essentially the technology goes back to powder metallurgy, such as metal injection molding and things like that. And those technologies themselves, like metal injection molding, also go back to the early 80s. So the Virtual Foundry has combined two reasonably mature technologies into a completely new one.
Most of the technologies in the metal 3D printing additive manufacturing space use powdered metallurgy, the Virtual Foundry included.
Right. What makes the Virtual Foundry unique is we've come up with products that work on simple, inexpensive printers that were originally designed for plastic. So this makes the technology very, very accessible. People do this at home. Our users range from people printing things in their home workshop to people creating new products in the national lab system. The scope is enormous. We've also been able to use this concept to sort of decentralize manufacturing. A major topic right now is that there are supply chain issues all across the world. And this started with COVID, but it actually seems to be getting worse. So, for example, some topical information. Right now, there's about 65 cargo ships stranded off the coast of California. They can't dock. And this is a huge part of America's economy, is literally stuck on ships offshore. So what the virtual foundry brings to the table is a method of fabricating parts in a very accessible, low-cost way.
And it's using, it's all based on powdered metallurgy, like you said. We've provided a different way to get that metal into a shape, but from there, you're really working with powdered metallurgy.
Right. So some of the strengths and weaknesses of powder metallurgy come through. So if you're talking about porosity and strength and all of those kind of things, there are methods to overcome each of those issues.
We've been researching lots of ways to fill in those pores for those applications that dictate that. There are many applications that prefer porous parts. There are some that don't mind porous parts. There are some that need solid metal objects. And we have done a lot of research on different ways to fill in those parts to end up with a solid metal object. We've got a couple of different infiltration techniques that I'm going to ask Brad to talk about in a second. But it all deals with powdered metallurgy, which is quite old. There's a lot of research out there on it. So any of the techniques that powdered metallurgy uses to create solid parts can be applied here. So Brad, just talk about those infiltration trials that you've done and what those look like.
Right. The easiest way to get to a fully dense part is to sinter it over a long period of time. What happens is the part will shrink. So geometrically, it'll shrink by about 15 to 17%. And at that point, you have a fully dense part. But depending on the part design, this may not be practical in some situations. So there's other things that you can do. And kind of the most interesting that we've been experimenting with is to add another metal that has a lower melting point than the one that you're working with. So we'll take a steel print and then essentially braze it. You can fill in all of the pores and all of the any of the spaces with bronze. And this is a very powerful technique, partly because you don't have any shrinkage. So you don't have the warpage that you tend to get when you're densifying larger powder metallurgy parts.
And we have talked about this technique that Brad is describing in another podcast, so I will link that in the description as well.
Right. And I'd like to talk a little bit about this method. We've sort of decentralized manufacturing, or this is our goal. We make it so not only is it accessible to everyone, but it can also be distributed across a greater geography, or however you want to look at it.
So Brad, talk about some of the progress that we've made here internally with powdered metallurgy or using powdered metallurgy.
Right. Probably the most interesting is the range of materials that we've been able to develop. So on our website, we have 14 materials that one can just go and buy, and we're adding new materials all the time. A new one coming online, silicon carbide. So that'll be coming out shortly. So we have high-tech ceramics, we have metalloids, we have cermets, just about anything that you can think of that can be sintered. We can make it into a 3D printing feedstock or 3D printing material. And we do this on a custom basis for labs all over the world. So we've made really unique products, things like moon dust simulant, just very strange things that you wouldn't necessarily think of.
Tell us about some of our customers who are using this technique that involves powdered metallurgy to make parts for themselves.
Right. For example, we have a group of engineers creating parts for basically obsolete parts that are no longer produced for relatively old coal-fired power plants. So since they can no longer source the parts, they've figured out how to make them using our materials.
And how about some of your favorite theoretical ideas that can use this technology?
Right, this just keeps going. Like in situ space manufacturing is an obvious one. Working with materials that are available off planet, or using this technology to work with whatever materials are present in whatever area you happen to be in. And this can range from metals to ceramics to glass. The ceramics are increasingly interesting. This was kind of it's part of our patent, but it was kind of the last material for us to bring online. So we have basic ceramics that work just like your typical pottery or hobby ceramic and things like that. But we're also getting into, like I said, the silicon carbide is a good example, where it's a high-tech ceramic used in very, very specific applications. The next things that will come along are alloys and different alloying agents. So we can either pre-alloy a material where it's melted and mixed together before you start, or we can blend two different powders that become a new alloy as it goes through the sintering process. These are the things that I think are going to make all of this much more interesting and start providing solutions to problems that really couldn't be solved before. And part of our challenge has been getting people to think about this as a new technology and not trying to go back and, we don't recommend that you print a trailer hitch. That's not a logical place to start. But a lot of people think 3D metal and that's where they start. But our users are starting to, our key users understand that that's not where the applications lie. The applications lie in solving problems either that weren't solvable before, or new solutions to complex problems that simply weren't available before this technology came along.
Now, how are powdered metallurgy, filament, 3D printing filaments that we produce, how are those in that process similar to, say, precious metal clay?
There's a lot of crossover. Essentially, precious metal clays are binder. Originally, they used rice or something glutinous or something organic, and it was the same type of a strategy. You would sculpt that by hand or mold it in whatever way you could, and then sinter it afterwards. Our material works in a very similar manner.
So we talk about decentralizing manufacturing, democratizing metal part production, and we do explore that topic more fully in our very first podcast, which I will link in the description here as well if you want to hear more discussion on that. Now, Brad, I do have one more very important question before we wrap up today.
All right.
Wait, I was going to tell a time traveling joke, but you didn't like it. There we go. Okay.
Nice. All right.
That was quite a pause. I was a little nervous there for a second.
Right. I had to work through it.
Say, everybody, if you've got a cool project that you want to talk about in this format, show it off, tell us what you're up to, reach out to me at info@thevirtualfoundry.com and we'll get you into a future podcast. Well, thanks for joining us, everybody, today, and we will see you next time.